Number one, let's find the inverse of this relation. Now look what this relation does. What it does, it takes negative 8, maps it over to 4. I'll draw a picture of that. So it takes negative 8, maps it over to 4, and then it takes 7 and maps that over to negative 7. So what we want to do is find the inverse of this. So we want to go the opposite direction. So if negative 8 goes to 4, we want 4 to go to negative 8. So I'm going to claim now that the inverse is, write a set. So I'm looking at this one here. Negative 8 goes to 4, so I'm just going to switch those components. I'm going to say that 4 goes to negative 8, and then the 7 goes to negative 7, so let's just back it up. Negative 7 will go to 7. So negative 7 will go to 7. So to do this, all we're going to do is switch the order of the ordered pairs. Let's find the inverse of this relationship here. So we've got y is equal to 5 times x minus 2. So the first thing I'm going to do is interchange x and y. So that will give me that x is equal to 5y minus 2. See what I did there? Up here at the top right, y is equal to 5x minus 2. I just switched the x and y, and that's pretty much what we did right over here, right? Here's an x, here's a y. To get the inverse, I just switched them. So I interchanged them. So that's what I'm going to do here. X equals 5y minus 2. Now what I'm going to do is solve for y. So to solve for y, first of all, okay, I'm going to write it here again. X equals 5y minus 2. I'm going to add 2, right? So let's add 2 to each side. I'll get x plus 2 equals 5y. And now let's divide by 5. So I'm going to divide each part by 5, each term. So this is really 1x plus 2 equals 5y. So I'm going to get 1/5 x plus 2/5. That's equal to y. Or how about y equals 1/5 x plus 2/5. I'm going to claim that that is the inverse of the original equation. What we want to do in this problem is to find the inverse of this relation right here, x equals y squared minus 1, and here is a picture of it right here. And the way we're going to do this is that we are going to reflect this graph around that line y equals x. So we need a little right brain activity here. We're going to have to just imagine what this looks like. Or another way to do this is to plot some points. Here's my plan to get the inverse. I'm going to look at points that are on this curve, get those points, and then I get the inverse just by switching the order of those pairs, right? Just interchange the pairs. So what's one point on the curve I can see? I can see this one right here. Right, that's on the curve. And what is it? That point, now this is on the red curve. Okay, I'll do it like this. This is on the red curve. It looks like x is negative 1 and y is 0. So if I switch these to get the inverse, if I switch them, I'm going to get 0 and negative 1. All right, so I'm going to go over to 0 and negative 1. Okay, x is 0, negative 1, and that's going to be on the curve. So it looks like it's right there. And in fact, it looks like it's even on both curves. So I'm going to plot that point. All right, so I'll plot that point right there. Looks like that'll be the vertex. Now let's get some other points that are on the curve. All right, so I'm looking at the curve here. Can I see a point? Yeah, how about this one here? That looks like it's on the red curve, which is, where is it? Actually, there's two of them here, right? There's when x is 3, y is 2, but when x is 3, y is negative 2. So here's what I get. When x is 3, I get 2 as well as negative 2. So I'm going to switch the orders. So switch the orders, I'll get 2 and 3 and negative 2 and 3. Let's plot those 2 points. So 2 and 3. So we're going to start the origin. We're going to go to the right 2, up 3. That'll give us that point right there. Over 2, up 3. I think it's right there. And then this last one down here is to the left 2, up 3. So to the left 2, up 3 is going to put us right here. I think I see a couple more points that are on the curve here. So I'm on the red curve now. If I come out here, it looks like if I'm over 8, I'm up. What? If I'm over 8, I'm up 3. So if I go over 8, I'm up 3. Let me get that one here. So if I go over 8, I'm up 3. And then also if I go over 8, if you look at the curve, you're down 3. So that's going to give it these 2 points when we switch those coordinates. Over 3, up 8, to the left 3, up 8. Let's plot those. So over 3, okay, over 3, up 8 puts me here. All right, let me plot that one. Over 3, up 8 is right here. And then to the left 3, up 8 is right here. Okay, I think I can see the curve here now, so let's plot that one. So as best we can, draw a smooth curve through these points. Not a sharp corner down there, right? A smooth curve. All right, I'm going to claim that this is the inverse. So this green curve is the inverse graph of the red curve. So what have we got here? We want to graph this equation, y equals 7x minus 7, by plotting some points, and then reflect the graph across the line y equals x to get the inverse. All right, so let's plot some points for this one right here. So let me write that curve here. What we have is y equals 7x minus 7. So it's a straight line, right? It's linear, so I just need really 2 points. So how about this? Here's an x and a y. All right, how about when x is 0? All right, put 0 in here. What do we get? We'll get y equals 7 times 0 minus 7. We'll get negative 7. So here's a point on the curve itself. 0, negative 7. So what's on the inverse? I'm just going to do it. The inverse is going to be this one here. Just switch the order. Negative 7, 0. So suppose now I pick x to be a 1, then y would be 7 times 1 minus 7. Well, 7 minus 7 is 0, so I get this point here, over 1, up 0. So if I switch the order, that'll put me on the inverse. So how about 0 and 1? Okay, I know it's a straight line, so I just need 2 points. Probably 3 is a check, but I'm just going with 2 here. So first of all, I'm going to get the line itself. So let's get, I'm up here at the top left, let's get this line, y equals 7x minus 7. Here are 2 points. So when x is 0, y is negative 7. I'll do this one in red. So 0 and negative 7, 0 and negative 7, all right, that's way down here. So 0 and negative 7 is right here. The next point is to the right 1, up 0, or down 0. All right, so 1 and 0. So let's get that one. 1 and 0. That's going to put me right here. 1 and 0 right there. So now I'll do my best to pass a straight line through these 2 points with my straight edge. So let's graph these points here. Now I think I'll do the line itself in green. So here's the line itself. I'm going to graph these 2 points right here. 0, negative 7. Right, so 0, negative 7 puts me down here. So 0, negative 7 is right there. And the next point, this one here, over here, to the right one at 0. So to the right one at 0 puts me here. To the right one at 0. Now I'll do my best to pass a line through these points. So it looks like I can get that line right there. That looks pretty good. All right, that's the line itself. This is the line y equals 7x minus 7. Now let's get the inverse. Now the inverse I'm going to get by plotting these points. So I'm going to go to the left 7, up 0. So I'll do this one in red. To the left 7 at 0, 6, 7. I think that's it right there. And then the next point is 0, 1. So 0, 1 is going to put me right here. Let's draw a line through those points. See if I can get that line. That looks pretty good. All right. Now, does it look to you like these 2 lines are reflections of each other about that line y equals x, the 45-degree line? I'll draw that. There's that 45-degree line. So does it look like if you reflected, say, the green line about that blue dashed line, that you'd get the red line? Looks pretty good. So I think we've got it. So the red line is a graph of the inverse of the green line.